one of our partners that we collaborate with, this is Esri's front-end web mapping applications. So what the beauty of that is, Kinetica, as we mentioned earlier, since we provide an OGC compliant web service for our map renderings, you can actually consume Kinetica maps and data from any of the web mapping providers, for example, that support that OGC specification, which is pretty much all of them. So whether it's Esri or you're an open source user, being able to consume maps that come out of Kinetica and integrate them into your existing applications is relatively simple. So in this case, we're going to go through a couple examples, and this first one we start off with is actually an example or a demonstration based off telco signal data. So the first thing I'm going to do here is turn on a map layer that is pretty noisy, right? So what you're looking at is basically raw mobile signal events, in this case in the Bay Area of San Francisco. And you're actually looking at each one of these white dots represents an individual mobile signal event over the period of a 90-day window that was provided to us by this customer. And by looking at this, you're probably thinking the same thing that I am, is that, that's a lot of information. It's very noisy. There's probably some corrections that need to happen. But I can't really tell anything beyond just where big blobs and messes of data are occurring. So when you look at the geospatial and visualization capabilities of what Kinetica offers, we have a couple different options and different ways to analyze this data. And my fundamental goal as someone who's looking at this to try to make sense of it is, how do I take this complexity of this data, the volume, the locations, and the underlying attribution about all these mobile signal events, and how do I turn that into something useful that I can then turn into an actionable event within my organization? So the first thing I'll do is I'll say, instead of looking at this as just a big blob of individual dots, maybe I'll want to look at each of those dots in a unique way, in the sense that I want to do a class break style renderer on it. And what that means is that I can then color code each one of those events based on an attribute value. So in this case, I'm actually color coding those events based on whether or not the signal strength of that mobile event was weak or strong within the given area. So the weak events are actually showing as purple, and the really strong events are showing as green. But again, in my mind, if I'm an analyst looking at this information, that there's still too much data, there's still too much noise in the map to really make sense of it. And being able to draw millions or even billions or trillions of events on a map is really neat. It's kind of a cool party trick, is what I like to say. But from an analytical standpoint, it doesn't really get you much insight. So that's where, again, we look at GPU compute workloads and the power of something like Kinetica and being able to execute geospatial functions becomes really valuable. Because what I can do with this then is, instead of looking at this as raw maps, I can do a spatial join function. And what that allows me to do is say, let's say I have an area of polygons that represents block groups within the San Francisco Bay Area. What I can do is I can actually join all those mobile events to those block groups, and then I can actually color code those block groups to say, show me the areas that are most highly concentrated with those mobile events, and I want to color those darker red. So fundamentally, what you're looking at here on this screen is the dark red areas show you concentrations of where you have high frequencies or high volumes of those mobile signal events, whereas the lighter areas are lesser block groups. And we can actually keep those spatial joins on large-scale data sets in a very performant manner with Kinetica. The next thing I'm going to do is I'm going to turn on a signal strength layer. So instead of looking at just the raw mobile event frequency, I want to look at the signal strength. I actually want to normalize it by the signal strength. And this actually becomes really interesting, right? So if I'm actually the telco provider here in this case, I might want to look at the analysis to say, where do I see high concentrations or high volumes of mobile signal events, basically where I see a lot of activity, and where does that overlay in terms of where I have strong or weak signals? So it's interesting here, as you look at the East Bay, as I look at the slider, the dark red areas are showing me, again, just to reiterate, where I have lots of mobile signal event data, but it's actually a lot of the darker areas here in the East Bay actually overlay with areas where I don't have very strong coverage. So as an organization, if I go back to the beginning of the analysis here, when we started off with all the just the white dots, and how do I turn that into analysis that's useful, is by executing these spatial functions, I can then say, as an organization, maybe we need to invest in these specific areas for infrastructure to be able to support the amount of users that we get consistently there. Or alternatively, maybe I want to look at areas where we have great signal coverage, but we don't have a lot of users. And maybe those are areas to target from marketing or sales campaigns for us to try to get more subscribers in those specific areas. So just taking a pause there. So, I think this is a really good and fundamental use case to explore with Kinetica. But on the flip side, one thing that we're seeing consistently is organizations that understand that there's primary use cases on the complexity of their data that they're trying to solve. But more and more, we're getting asked on GPU workloads to say, how do I actually take that same data that I'm analyzing for that primary use case and turn it into an asset in a different way I hadn't thought of previously? So I'm going to switch to a slightly different application. And
Noyan, before you move off, how much data were you analyzing there? I mean,
that's actually a great
are
point.
we talking about millions, or what is the data set?
No, so this data set was actually 14 billion records. It's billion with a B over the course of a 90-day window for this particular customer. So that is, that's a scale of data that we're talking about in terms of analyzing and processing. Thanks, Dipti. So let me just set up this demo before we actually go through the interactions. So you're actually looking at a subset of the same data that we were just looking at in the telco analysis. So what this demo has done is we've actually pulled out an individual unique mobile subscriber. Obviously, it's been obfuscated and it's been anonymized. But we're looking at a single mobile subscriber's event history over the 90-day window that we had from that same data set. So we pulled that out. And what you're looking at is that the larger areas, the larger circles that you see on the map are actually representing we're basically done cluster analysis to analyze where that individual mobile subscriber has spent more than 90 minutes at any given point in time over that 90-day window. And then basically we're rendering those on the screen. And the larger the circles are basically where you have higher concentrations or longer periods of dwell time for that individual. So what does that look like when you're looking at the map? So for me anyway, I can pretty safely assume that I can pretty accurately tell where this individual lives and works. And I can probably assume that it's right here just because you have really high concentrations of larger circles, and there's more than just one, right? So it's not a unique event. So I can kind of safely assume that both of these two areas are probably where this individual lives and or works. But more importantly is we can actually do spatial analysis to understand what's around those areas, right? So we can specifically pinpoint based on those exact locations. I can understand that this user, how much time this individual spends in a certain type of a facility or business type or so forth. So in this case, I can see in this chart how much total time over the time window of data this person has spent in a private residence versus in a private business versus in transit versus in a restaurant bar or in a business that's labeled as a fitness health facility or a municipal office or whatever it is, right? So I can kind of classify where this individual spends all of their time. More importantly is that if I overlay the additional information about when this user or all the movement activity about this user, I can actually reconstruct the routes of where this user has spent their time and how they've actually gotten to those locations, right? So I can actually replay and reconstruct how this individual has gotten to all the individual locations that they've spent the majority of their dwelling time within the given data set, which is really powerful. And you can actually see that the darker areas are representing the routes or the paths that were most frequently utilized by this individual over that period of time. And then lastly, if we focus on the high activity routes, that's kind of what we're looking at here. We can actually see the total unique impressions per route. And what this is basically telling us is from an advertiser's perspective, I would like to know that for this individual, I want to know how many unique businesses that or storefronts that this individual passes over as they traverse each of those individual unique routes on a total aggregate basis over this time window. And then lastly, for this particular customer who wanted to analyze this data set, they basically wanted to provide a scoring algorithm for this individual to be able to say, based on all this information that we're looking at over the period of time, let's basically give this individual a score that determines their marketability for us to be able to determine how valuable their data is, of course anonymized, but how valuable that data is to potential other businesses or even internally within the organization. Any thoughts?